This question is titled, How do I identify simple patterns in text? And what we're going to talk about is, what are the fundamentals of the regular expression syntax, the regular expressions that you have in tools like the RE module in Python, in tools like egrep, in tools like your Vim editor. What is that core syntax? How do I use that core syntax to specify alternation, to specify quantification, to specify the position of matches? What are some helpful things that I might use, like character classes and character sets? In Python specifically, what is a match object and what can I do with it? And largely, how can I build just a little bit of mechanical sympathy to understand how regular expressions work? And so why don't we take a look? Here is the general format of pretty much everything that we're going to do. I'm going to take some pattern. I'm going to compile that pattern into a regular expression. I'm going to take some text, and I'm going to call a method on this regex object. Either I'm going to call search, match, find all, find iter, or full match. And probably I'll limit myself to just find iter and full match. But let me show you what these are all about. Basically, what we have identified when we choose to use regular expressions is that we're doing enough textual searching and extraction and substitution and other similar tasks that we want to find a way to tersely, precisely express the patterns that we see. We don't want this to just be in a bunch of nested if-else logic with string.split and string.partition and string.strip and string.casefold and all of those mechanics. It's going to be very hard for somebody to read, very hard for somebody to debug, and it'll be very specific to the programming language that you wrote that in. We want to find something a little bit more general, where these patterns might be usable across many different tools that support this underlying pattern language, this language called regular expressions, and where we can very tersely express what a pattern looks like. And so the starting point for this is always going to be some pattern and some text in that pattern. Now, before I actually do anything with my pattern, I'm going to choose to compile this regular expression, and I'll show you why I choose to do this. Largely, it's just for the API. Once I've compiled this regular expression, I'm going to call some method in order to perform a match. Now, regular expressions can do things like substitutions, but for the most part, we're just going to look at matching because you can think anytime you can do a match, you could just replace the part that you matched with some computation off of what you matched. So the substitution doesn't really add a lot. In Python, in the RE module, there's a distinction between searching and matching, and I can never remember which is which, so I basically never use search or match because you know what? I really genuinely cannot remember which is which. One of them starts from the beginning of the string, one searches through the entire string. It's just not worth my time to try and remember that every single time. I honestly don't even use find all. What find all will do is it'll take a pattern and it'll search for every instance of that pattern in the string and give you the actual string matches that it had. But that's kind of tricky because I actually usually, when I want to find a lot of patterns, I want to extract something. So I don't really even use find all that much. I'm going to focus almost all of my attention on two parts of this API, find iter and full match. Full match takes a regular expression and matches the entirety of that against a single string. And find iter looks for every possible match. And you're going to see generally two modalities that I have. One modality is I'm going to be matching one line at a time using full match, or I'm going to be taking a block of text and finding all the patterns in that block of text. Because you can see this is a multi-line block of text, and I'm looking for every instance of A, B, C, D, E. I'll find it here or here. And I'll do that using find iter. Or I might, in Python, loop over this line by line and apply a full match to each individual line. And those are generally the two modes in which I find the majority of my regex usage falls into. Now, bear in mind, we're going to talk a little bit about how we can blend our use of Python and regular expressions so that we don't go overboard with some of the sophistication of regular expressions, but lean on what it's able to do effectively for us. And also just step in with a little bit of Python here and there to make our lives easier. But I want to dive into one or two of the small specifics of what you see in this example. And the first part of that I want to dive into is here. I really do have these two modes. I can either perform some string processing, like I can strip white space from the beginning and end of this text and I can split it on lines and do a full match on every single line. And you can see A, B, C, D matched here, didn't match here, matched here. Or I can search through this entire string and find every match. You can see it found two matches, one at the beginning and one at the end. There are some tricky things about doing multi-line regular expressions that we won't have a chance to get into in too much depth, but you can see both of these modes more or less cover a lot of, maybe 90% of the types of tasks we have. Now there's another thing that I want to draw your attention to, and in order to do that, I'm going to create a very simple timer here. Why do I compile this regular expression? Well, here's how the regular expression actually works. When you tell the RE module to do something like a find iter or a full match or a compile, it first takes that string and it has to parse it. It has to figure out what does that string specify, what's the pattern it's specifying. And after it parses it, it's going to build a finite automata or something close to it, more or less a state machine, and that state machine is going to perform the matching. What you can think is, if you had just regular old Python code to do for line in some text, line.strip, if string, substring in line, line.split, line.partition, all of those mechanics, well, if you looked at that, you could form those mechanics into a simple state machine where each individual line of code is some particular state, and the if-else's are the branching between the state machine. Well, what the regular expression is doing is it's computing a much more efficient state machine than what you can express in pure Python, because obviously pure Python is very dynamic, and it's running the text against that state machine to perform matches. We'll see a little bit more of what that might look like. We'll be able to get a little bit of a sense of what that might look like behind the scenes. There's a lot more complexity to it. We have to think about things like NFAs and DFAs. But for the most part, what this compile step is doing is it's building the tool that will perform the match. Basically, I can either build the matcher ahead of time and then continuously reuse it, or I can rebuild it every single time. And if I run this code, you'll see for one match, compiling actually is going to be slower than compiling each time. Compiling once ahead of time is going to be slower. And in fact, what's kind of surprising is it takes quite a few matches, about 100 or more matches, before I can really see a significant difference between compiling up front or compiling each time. Here at 100,000, I'm saving myself 0.06 seconds for 100,000 regex matches. If I'm doing 100,000 regex matches in pure Python, this is not going to be fast anyway, so this compilation isn't really gaining me too much in practice. The reason why I'll always compile this ahead of time is it just makes the API look a lot easier. Instead of having to import a bunch of things from the RE module, I can just call methods on this thing corresponding to the pattern itself, or corresponding to the regular expression, the state machine itself. And so for the most part, we won't talk too much about, what the efficiency is of at least this simple distinction between either a precompiled or a postcompiled regular expression. Now, bear in mind, this is not really a fair comparison because internal to the RE module, there is a cache. So when you run the same regular expression over and over and over, it'll actually use that cache to pull out the previously compiled version. The distinction between the compile up front and the compile each time will be much more significant the more complex a regular expression gets. But here, if I really wanted to make this a fair comparison, I would purge the cache in between. But again, you have to get a really complex regular expression and a lot of matches before this really makes a difference to your everyday life, where it really makes a difference at the speed at which Python is operating. And so we're not going to think about this too much for performance just because it's not the most compelling place for us to improve the performance. Another thing I want to draw your attention to is what this string with the R at the beginning is. And you've probably seen this before. Here I have a Windows path. And this Windows path is for a user named Travis, except that \t that appears in that path is being interpreted as a tab character. And so if I want to represent this user's documents directory, I have to escape the backslashes, because the backslashes could be misinterpreted by Python as a new line, a form feed, a vertical tab, a carriage return, a regular tab, a horizontal tab. And no, I want to say this is actually a backslash. This is the path separator that we use on Windows. But this starts to get real ugly. And so instead, I will use a raw string. A raw string in Python is a string where the backslash escapes don't actually work unless it's escaping the character that's containing the string itself. Where this really comes up is if any of you have UNC paths like Samba or Samba shared directories, an actual UNC path starts with double backslashes. And so if I wrote it like this, you can see, the /f is a form feed, the double backslash turned into a single backslash. I actually have to duplicate every one of these backslashes. This is so difficult to read. So instead, I'll write it like this. So this is why I always use that raw string. The regular expression language itself can contain things with backslashes. Part of its specification is certain entities that contain backslashes. So I want to make sure that those are being interpreted as part of the regular expression, not as something else. For example, a \b is a backspace character in ASCII, but in regular expressions, it's a word boundary. So rather than having to write something like this and having to remember to escape it every single time, I'll use a raw string. Now, having seen some of the core mechanics of how I'm going to set everything up, why don't we take a look and a very quick look at all of the basic syntax of regular expressions. We'll start with alternation. Sometimes you don't want to match one exact thing. You want to match one thing or something else. Here, I want to match ABC or XYZ. So let me run this. It matched ABC. Great. Let me switch my text out to DEF. It didn't match DEF. Great. Does it match Does it match XYZ? It matches XYZ. Simple alternation uses a pipe character. You put the two choices on the two sides of the pipe, and you're good to go. And if you wanted to, we could extend this further. We can do a triple alternation here, so it'll match ABC, XYZ, or DEF. It'll match any one of those. Now, it may be the case that that alternation or that choice that you want to have includes elements that you don't want to presuppose or you don't want to write out, like maybe any possible character. Maybe you have some date format and you don't know what the date separator is going to be. Maybe it's a dot, maybe it's a slash, maybe it's a dash, maybe it's anything that the user can come up with. And you don't want to have to use that alternation over and over and over again. So what you can do is you can use a single dot to represent any character. So this regular expression will match any character followed by a B, then a C. And so here it'll match ABC, it'll match XBC, but it will not match XXXBC because it matches any one single character. This is our basic globbing character, our basic wildcard character. It matches any one character, but it doesn't matter what that is. This could be a tab character, it could be a number, it could be anything, but it'll match it as long as there's just one of this. Now, if you think about how we might do something like that date example, we don't want to match anything because really separating dates, maybe you have periods, you have slashes, you have dashes. That's basically about all that people are going to use. If you have like $signs in between the components of a date, that'll be very weird. So maybe you want to specify those three things, but you don't want to specify it as slash or dash or dot. And you have to escape the dot because you want to actually match an actual period, not any possible character, and that's going to get a little bit messy. So what you'll do is you'll use a character set. In square brackets, any single character in square brackets matches. So here, this will match ABC, XBC, but it won't match ZBC. So you can see it matches ABC, it matches XBC, but it doesn't match ZBC or ZBC. And so if you think about it, what you could do for your date is you could say, well, I'm going to match a number. We don't quite know how to do that yet. So here's what I'll do. I'll say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to match a dash, a slash, or a period. And here I don't have just one of these for a date. I got 4 of these in a row. So there we go. Oh my goodness, this is so tedious. But at least I can specify any one of these possibilities pretty easily. And then through the magic of cut and paste, I can get the month and the year. There we go. And so this will match any possible date format. It'll match that. Oh, let's double check. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 4 of those. We have a dash, a slash, or a period. And we don't want one of these at the end. There we go. Or it'll match this with slashes, or it'll match this with dots. Now this portion is really painful to write. I don't want to specify every single character, so what I might use is a character range. I can match any character to any character on the ASCII range. It's very important because if you think about how ASCII is laid out, the capitals come first, the lowercase come later, and there may be some characters in between when you don't really expect it if you're in a particular mode, like if you're in the Unicode mode. Here, this matches any character from A to Z, including A, including Z, and then a B and a C, any one character. So it'll match ABC, it'll match XBC, but it won't match 0BC. And so if I take my date regular expression here, and bring this forward, and I try and write it a little bit better, I can write it like this. And you can see this is already an improvement. The single dash has to occur at the beginning of the character set if your intention is for it to mean an actual dash character. Because if I write this, a dash, a slash, or a period, which I want to be an actual dash, an actual slash, or an actual period, I actually need to probably, now I think that actually, let's see something. That actually means an actual period here in this. But if I put the dash in between these, this will mean anything from a slash to a period character, and this character range is nonsensical. So I have to put that dash at the very beginning. But here you can see I have my simple date regex, and it'll match any date either with dots in between, with dashes in between, or with slashes in between. If I want to try to specify anything that's not part of a set, I can put a caret at the beginning, and the caret at the beginning means anything that's not in this set. So this matches anything that is not A or X, so it won't match A, B, C. It won't match X, B, C, but it will match Y, B, C. And I can do the same thing with character ranges. So here it won't match any lowercase letter, A to Z, but it will match an uppercase letter or a number or something like that. There are common character ranges that are used, and they're used over and over and over again. And to make your life easier, they have been specified ahead of time. And so any space character, a tab, a vertical tab, a form feed, a new line, a carriage return, or an actual space character can be expressed as a \s. So this will match any single space character. Here, if you take these common character ranges and you uppercase them, it means the negation of this. And so here, this means any non-space character. This is the same thing as taking this regular expression and just putting a negation. Anything that's not a space can be represented like this. Similarly, if we wanted any digit character, here I can say 0 to 9, or I can say /D, and a slash capital D just means any non-digit character. And so if I were to rewind to this regular expression and I want to write it a little bit better, I can now write it like this, with 2 digits here, and let's see if we can do this, 4 digits here for the year. So that's a little bit nicer and a little bit shorter. Here's where it starts to get a little bit ugly. If I have any word character, that means any uppercase or lowercase or digit character, anything that's not a space character or a punctuation character. And there is a \W for any word character, but what is actually contained in that word character? Well, now you're beginning to think, hold on a second, there's a lot of languages in the world that are not English, and A to Z doesn't include any of the special characters in any of those languages. A to Z, 0 to 9 doesn't include these. By default, in Python 3, these character ranges are interpreted in terms of Unicode. There is an ASCII flag that allows you to turn off that behavior, but you may start to see some strange things when you deal with Unicode, matching Unicode text. And I'll show this to you with the digit regular expression. Here, this digit regular expression will match. Here, let's get this one as the one that we're going to use. This thing will match any digit. So it'll match any Arabic numeral that you see as a key on your keyboard. Will it match Chinese digits? No. Will it match Tamil digits? Yes. I don't know why. Well, I do know why. If you dig into Unicode, it will tell you that these different characters have character classes associated with them. And the Tamil digit for 1, onu, right, has this special character category for being a digit, but the Chinese, formal 1, E, doesn't. So you can see this starts to get really ugly because we have to know a lot about how Unicode is laying out the characters for our language before we're actually really able to use this. And so for the most part, we're not going to look at matching its Unicode strings because it becomes really complicated unless you really know a lot about the target language. For the most part, for a date or something like that, probably we're not going to see these kind of characters appear. Now, if we want to represent a match that might be one element or two elements, one or more, 2 to 5, 0 or more, we have quantifiers. So here, this matches exactly A, B, and C. But if I wanted to match A, B, and C, or A, B, and C, I could put a plus after this. The plus means match one or more of this character. And in fact, there's quite a few of these quantifiers that I can use. A question mark means 0 or 1. A plus means 1 or more. A star means 0 or more. And in curly braces, you can say from some number to some number, a closed interval. And so here, this means match anywhere from 3 to 7 A's and then a B and a C. So in order to make this match, I have to have 3 up to 7. If I give more than 7, it won't match anymore. If I were using this one, I need to have 0 or more of them, so it'll match with any number of these, up to and including none. Here, this means 1 or more, so I need to have at least one of these. And this means 0 or one of these matches. Now, I can then use a little bit of this to improve my previous date regular expression, because if I wanted a regular expression for a date, I could do that just like this. I can say 4 digits with any one of my digit specifier, one of my digit separators, plus 2 digits, any one of my digit separators, plus another 2 digits, and now this will match any possible date format that, or at least any one of the ones that I'm willing to allow. So it'll match this date format, it'll match this date format, and it'll match this date format. And if I really wanted to, I could quantify these, and I could say these are optional, 0 or 1. Then it will even match if somebody doesn't put in a specifier. It's pretty useful. We can specify where in the string we want to match. A caret means to match at the beginning, and so this will match an ABC if the string happens to start with, ABC. So if the string starts with something else, like XYZ, won't match. Now you can think, when you think about the dot search and the dot match from the RE library in Python, they also say, oh, do you match from the beginning or end? This is why we don't really need to use it that much. Often find iter and full match are sufficient because you can specify at the beginning or at the end. Full match actually means implicitly you have a caret at the beginning or a $sign at the end. The $sign means look for the match at the end of the string. So here you can see XYZ ABC. This should, well, this won't full match, but this will regular search. Or if I find iter, it'll work with a find iter. Now, another useful thing is a \b, which means match at a word boundary. And this is especially useful if I'm doing a find iter. It's not really useful if I'm doing a full match, because a full match says I'm matching the entire string with an implicit caret at the beginning and $sign at the end. The find iter means I want to match ABC and then a word boundary, any non-word character. So I want to match ABC by itself, but not ABCD. I don't want to match it when it's a little bit too long. I don't want to match that entire thing. So you can see here, if I use this together with find iter, it matches just the ABCs, but not the ABCD, because it says, oh, I'm matching an ABCD that is not followed by another word character that's only followed by some sort of punctuation or space character. Of course, if we're going to do this on Unicode strings, or if we're going to do this with Unicode characters or with characters outside of our basic ASCII characters, we have to be very aware of what the character categories are, but we'll leave it at that. There are a couple of flags that I can set for my regular expressions. Ignore case means ignore cases in the matches. So here, match all lowercase, match all uppercase, do this case insensitively. Pretty straightforward. ASCII means turn off that fancy Unicode matching and just match, if I'm asking for a word character, match actually just the ASCII A to Z 0 to 9. And so here, if I match this with any word character, it'll match hello, it'll match tschüss, it'll match my Chinese here as well. Will it match my Tamil? No, it doesn't match my Tamil, it doesn't match Varnakam, right? If I turn on my ASCII mode here, none of these will match because this will only be considered ASCII. And this is where it gets really unpleasant when we're dealing with this Unicode, because we have to really know a lot about how Unicode is laying out these characters. In the case of something like my Tamil Varnakam, the reason it doesn't match this particular word is if you break this up, you can see that in languages like Tamil, you have the consonants and then you have the vowels that get added on top. And as a consequence of that, the vowel markers are their own characters. Those vowel markers have an MN character class, not an LO. LO means lowercase letter. MN means non-space mark. That is not considered a word character, and as a consequence, the diacritics that are used in Tamil to indicate that this is a terminal sound is causing this to not match as a word character. And what's a little bit shocking is you can think in German, my Tschüss should be the same way, except this U with an umlaut on it is a single character, and if I normalize this Unicode text to decompose it into the U and the diacritic, then it no longer matches. So it gets really, really complicated because we have to know, does Unicode have pre-composed letters for these single letters with the diacritic attached? And is my data already normalized so that they're composed? Because you can see, depending on whether I have this tschüss with the U and the umlaut as one character, or this tschüss with the U and the umlaut as the U and then the diacritic as a separate character, it may or may not match with a full word match. So, for the most part, we're going to deal just with ASCII strings when we're going to be matching, because we really need to know a lot about how Unicode lays out these characters to very confidently be able to do this. And I am genuinely curious what you're supposed to do. If you happen to be running an e-commerce website in Chennai, how do you match strings that you're looking for in customer orders? I don't know, because there's no pre-composed vowel consonant characters in Unicode as far as I understand. So I really do not know what you do. Now, another and the final thing that we're going to look at is, for the most part, we're going to either assume finding every iteration through a string. When we do that beginning and end, that beginning and end assumes the very beginning of the string and the very end of the string. So if it's a multi-line string, you mean the very first line or the very last line. With the multi-line flag, you can actually say, oh, the beginning and end means the beginning and end of a line, which is often something closer to what we want to do. The dot all means that the dot will match anything up to and including a multi-line, like a new line character. Typically, this the dot character matches anything except this new line. With the dot all, it'll match the new line. For the most part, I don't really use these. At the point where I have to mess around with these flags, I'm usually just using a little bit of Python to split this into one string per line, and I'm just calling it a day, because there's only so much complexity I can really tolerate before this starts driving me mad. But with that said, we have a very nice, very quick, very brief introduction to the basics of regular